doing trig equations with a basic 8. So that means if you see a tangent, you can change it to sine over cosine. If you see a sine squared, you can change it to 1 minus cosine squared. So basically anything that is a trig, you could replace it with some sort of identity to try to solve your equation. So for the first section, the instructions say to solve for x on the interval where our angle x is between 0 and 2 pi inclusive. Notice that interval is in radians, so all of our answers need to be in radians, so nothing in degrees. So problem number 1, we have sine of x plus sine of x cosine x is equal to 0. Now our goal today is to have only one trig. So we don't like this equation because it has two of them. It has sine and it also has cosine. So we need to try to get rid of one of them, but we really don't have an identity we could use for sine, and we don't have an identity we could use for cosine. But what we can do is get the trigs on opposite sides. So instead of having both of them on the same side, let's move this one to the right side of the equal sign. So let's subtract sine of x, cosine x to both sides. So that leaves us with sine of x is equal to negative sine of x, cosine of x. Then once you have trigs on both sides, so we have a sign on the left and a sign on the right, what happens if I divide both of these by sine of x? Both of these would cancel. But I'm going to make this a negative sine of x. So when I divide sine of x by negative sine of x, that gives me negative 1. Negative sine of x, negative sine of x, those cancel, and that leaves us with cosine of x. Now I just have one trig, and now it's ready to solve. So we need to find the angle whose cosine is negative 1. And what is that angle? Pi. Next one, number 2. We have tangent of x is equal to cotangent of x. Now we don't like this one because it's two different trigs. So if it's two different trigs, we try to get them on opposite sides, but that's already done. So another thing we could do is use an identity. So instead of tangent, what can I change that to? Sine over cosine. So instead of tangent of x, this would be sine of x over cosine of x. Drop down the equal sign. And instead of cotangent of x, I could change that to cosine of x over sine of x. And now I have a proportion. So to solve a proportion, cross multiply. So sine of x times sine of x would be sine squared of x. And for the other diagonal, cosine of x times cosine of x gives us cosine squared of x. Now that's better because I no longer have fractions, but do I have the same trig? Do I have a sine and a sine, or a cosine and a cosine? No. I want them to be the same. So if you notice, we have a square. So if you have a square, then an identity we could replace one of these with would be a Pythagorean identity. Remember, sine squared plus cosine squared equals 1? What could I replace cosine squared with? Yeah, cosine squared is equal to 1 minus sine squared. So instead of cosine squared, change that to 1 minus sine squared of x. The left side, drop it down. Now we have the same trig function. So now we can go ahead and finish solving this. So we need to add sine squared to both sides. So sine squared of x plus sine squared of x gives us 2 sine squared of x. That equals 1. Divide both sides by 2. So sine squared of x equals 1/2. And the inverse of squaring would be 2 square root. And when you square root, what do you have to remember? Plus or minus. So this would be sine of x is equal to plus or minus square root of fraction. So square root of 1, the answer is 1. Square root of 2, I'm going to leave it as square root of 2. But we need to rationalize that so it looks like our unit circle value. And when we rationalize that, we get sine of x equals plus or minus square root of 2 over 2. So now we are ready to write our answers. How many answers will we have? 4. All 4 quadrants, because sine is positive in quadrants 1 and 2. Sine is negative in quadrants 3 and 4. So we'll have 4 solutions. So what would be the solution in quadrant 1? Pi over 4. What about in quadrant 2? 3 pi over 4. What about in quadrant 3? 5 pi over 4. And in quadrant 4? 7 pi over 4. So you have to have all 4 answers to get credit. So if you forgot the plus or minus, you would be leaving out half of the solution. So you would only be half right. So if you take the square root, you have to have the positive answers and the negative answers. Next one, number 3. We have a secant squared, we have a tangent squared. Are those the same? No, so we need to replace one of those with a trig identity. So if it's squared, it's most likely going to be a Pythagorean identity. So over here we'll have sine squared plus cosine squared equals 1. If I have a secant squared, what would I need to divide by? Cosine squared. So sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared would be secant squared. So back to my equation, instead of secant squared, what can I substitute in for secant squared? Tangent squared of x plus 1. Then we'll need to distribute that too. Then we'll have plus tangent squared of x minus 3 equals 0. So secant squared of x, we replaced it with an identity. Tangent squared of x plus 1. Now distribute our 2. So 2 times tangent squared of x would be 2 tangent squared of x. 2 times 1 is 2. Plus tangent squared of x minus 3 equals 0. Combine my terms, so 2 tangent squared plus 1 tangent squared would be 3 tangent squared of x. And 2 minus 3 is negative 1 equals 0. It's tangent by itself, so we'll need to add 1 to both sides. So that would be 3 tangent squared of x is equal to 1. Divide both sides by 3. Okay, so that gives me tangent squared of x equals 1/3. Square root both sides. Then when you square root, what do you need to remember? The plus or minus. So tangent of x is equal to plus or minus. Square root of 1 is 1. I'm going to leave this as square root of 3. And when you rationalize that, this would be tangent of x is equal to plus or minus square root of 3 over 3. And now tangent by itself, so now I can solve it. So I have to figure out what angles have a tangent of positive or negative square root of 3 over 3. How many answers will we have? 4, because tangent is positive in quadrants 1 and 3, and tangent is negative in quadrants 2 and 4. So you have to have all 4 solutions to get full credit. So what would that solution be in quadrant 1? Pi over 6. And quadrant 2, 5 pi over 6. And quadrant 3,
7 pi over 6.
7 pi over 6. And in quadrant 4,
11 pi over 6.
11 pi over 6. So you have to have all 4 solutions to get full credit. Now, if you forgot the plus or minus, you forgot half of the answers. So make sure if you take the square root, you'll have the positive and negative solution. Number 4, I see a sine squared, I see a cosine squared. Do I want 2 different trigs? No, so I need to replace one of them. Which one do you want to replace?
Sine squared.
So instead of sine squared, what could I put?
1 minus cosine squared.
Yes, it would be 1 minus cosine squared of x is equal to 3 cosine squared of x. So now I'm happy because I have the same trig. Now get them to the same side, so we need to add cosine squared of x to both sides. So that gives us 1 equals 4 cosine squared of x. Divide both sides by 4. That gives us 1/4 is equal to cosine squared of x. The inverse of squaring would be square root. And when you square root, what do you have to remember? Plus or minus. And what's the square root of 1/4? 1/2. How many answers will we have? 4. So we have to figure out what angles have a cosine of 1/2 or negative 1/2. What would be the answer for quadrant 1? Pi over 3. What about quadrant 2?
2 pi over 3.
2 pi over 3. What about in quadrant 3?
4 pi over 3.
4 pi over 3. And what about quadrant 4?
5 pi over 3.
5 pi over 3. You have to have all 4 of those to get credit. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay, number 5. Now the instructions change for us. It says to solve for the principal values of x. The principal values, functional values, the instructions are the same. And we need to recall that sine is functional from negative pi over 2 to positive pi over 2 inclusive. Tangent is the same, but it's not inclusive. And cosine is the one that's different, and cosine is functional from what to what? 0 to pi. So we're going to solve these the same way, but we need to restrict our answers to those particular intervals. So number 5, I see a cosine and a cosine. So I like that because it's the same. So get them to the same side. So I'm going to subtract 3 cosine of x to both sides. So cosine of x minus 3 cosine of x would be negative 2 cosine of x, and that equals negative 2. Divide both sides by negative 2, and that gives us cosine of x is equal to 1. So cosine is by itself, so I'm ready to solve. But I need to remember that if I'm trying to find principal values for cosine, my answer should only be from 0 to pi inclusive. So what angle has a cosine of 1? 0. What about 2 pi? 0, 2 pi, they're at the same spot, right? 2 pi, is that within that interval of 0 to pi? No, so 2 pi could not be included as an answer, so it's just 0. Next one, number 6. Let's see, I see a cosine, a cosecant, and a cosine. What can I do? Divide both sides by cosine. What's going to happen? The cosine will go away. That leaves us with cosecant of x is equal to 2 Instead of cosecant, what could I change that to? Sine. So if the cosecant is 2, what is the sine?
1/2.
1/2. Now, we're still dealing with principal values. So sine is functional from negative pi over 2 to positive pi over 2. So what angle has a sine of 1/2?
Pi over 6.
Pi over 6, 30 degrees. Is pi over 6 between negative pi over 2 and positive pi over 2? Yes. So that's the only solution. Pi over 6. And number 7, I see a cotangent, a sine, and a cosine squared. So I have 3 of them. What could I do?
Do you find an identity?
We could use an identity. We have a cosine squared, we have a sine. What about cotangent? What could I do with cotangent? Yeah, let's change cotangent to cosine over sine. So this would be square root of 3. Instead of cotangent of x, we'll change that to cosine of x over sine of x. Sine of x, I'll put that over 1, minus 2, cosine squared of x is equal to 0. And when I multiply these 3, what happens? Yeah, sine of x, those go away. So this is just square root of 3 times the cosine of x minus 2 cosine squared of x.
It's plus 2.
Oh, sorry, this was a plus 2. So that should be plus 2 cosine squared of x. Now it should also be a 6. Now that's better because now we have 2 cosines. But if you have 2 of the same, what's the trick?
You can pass on.
We're doing factoring on Monday, so hold that thought over the weekend. Yeah, move one to the other side. So let's see, we could subtract. I'm going to subtract the one with the square root of 6, so I won't have to rationalize it. So subtract square root of 3 cosine of x to both sides. And that would give us 2 cosine squared of x is equal to negative square root of 3 cosine of x. What can I do next?
Divide by 2.
I heard divide by 2. I also heard divide by cosine. Let's do both. So over here, those 2's cancel. Cosine in the denominator will cancel only 1 in the numerator. So that leaves us with cosine of x is equal to cosine of x, those cancel. So cosine of x is equal to negative square root of 3 over 2. Now, to find our answer, again, this is in the functional section. So cosine, where is cosine functional?
0 to pi.
From 0 to pi. My answer has to be between those values or equal to those values. So what would the angle have to be?
5 pi over 6.
Yeah, I agree. 5 pi over 6. Is 5 pi over 6 between 0 and pi? Yes, it is. 5 pi over 6. And the next one, number 8. Let's see, I see a tangent, a sine squared and a tangent. What could I do?
Divide tangent.
Divide both sides by tangent. So that gives us sine squared of x is equal to 1. The inverse of squaring would be square root both sides. So that gives us sine of x is equal to what? Positive or negative 1. Now we're still in the functional section, so where's sine functional? Negative pi over 2 to positive pi over 2. So what angles have a sign of positive 1 and negative 1?
Negative and positive pi over 2.
Positive and negative pi over 2. The sign of positive pi over 2 is positive 1, and the sign of negative pi over 2 is negative 1. So we'll have two answers for that one. And are both of those answers within this range? Yes. Look at the sign, it can equal negative pi over 2 and positive pi over 2. Okay, number 9, this is a new one for today. It says solve for all values of x. So that means don't just do one rotation from 0 to 2 pi. That means you can keep going. So you can keep circling around that unit circle and making revolution after revolution after revolution and finding all possible angles. So let's get started. Here's number 9. I see a sine square, I see a sine. If I see two of the same on the same side, one of them needs to move. So I'm going to move the one with the minus, that way it changes to positive. So add sine of x to both sides. So that leaves us with sine squared of x is equal to sine of x. What's next? Divide both sides by what? Sine of x. So sine of x in the numerator will cancel one factor in the numerator. Sorry, sine of x in the denominator will cancel one factor in the numerator. So that leaves us with sine of x is equal to 1. And what angle has a sine of 1?
Pi over 2.
Pi over 2. But I could make another revolution. And what would that angle be?
5 pi over 2.
Yes, 5 pi over 2. If you count by pi over 2, this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So if I make it back, that would be 5 pi over 2. And if I made another revolution,
9 pi over 2.
that would be 9 pi over 2. So here's all of the solutions so far. We got pi over 2, 5 pi over 2, 9 pi over 2. I'm going to put dot, dot, dot. That pattern continues. But when we write our answer, we are going to write our answer as a recursive formula. Kind of like what we did with the asymptotes for tangents. We're going to do something similar here. So our official answer is going to be x equals. And you're going to put the starting or first solution. So what was the initial solution? Pi over 2. And then you have to state how much has to be added to get to the next one. So if I start with pi over 2, what do I have to add to get to 5 pi over 2? 2 pi, which is one revolution, right? I made one complete revolution, which was 2 pi. But if I add 2 pi, that only gets me to 5 pi over 2. So my formula needs to include something to where it would keep going. And remember that something, remember that constant k we used before? And we put the comma to say where k is an element of the integers. And that gives us our additional angles, or the additional revolutions around that unit circle. And the more common way to achieve it, usually in mathematics, that pi symbol is at the back. So if we put pi in the back, this would be 2k pi, where k is an element of the integer. So this is the one that's typically seen, the pi at the back. So how did we come up with that formula? This pi over 2, that is your initial solution. And this 2 pi, this is what you add to get to the next solution. So your initial solution plus however much has to be added to get to the next solution. Then you have to have the K to show that it keeps going, keeps going, keeps going. Revolution, revolution, revolution. Okay, number 10. Now, you only have to do that when it says to solve for all values of x. If you see that word all, you have to use a recursive formula. Last one, number 10. I see a cotangent, a cosine squared, and a cotangent. What can we do here? Divide both sides by cotangent. So that gives us cosine squared of x is equal to 2. The inverse of squaring would be square root. So square root the left side, square root the right side. And when I square root, what do I have to remember? Plus or minus. Now, is just a regular square root of 2 one of our unit circle values?
No.
No, so this one you'd have to put in the calculator. So do second cosine of square root of 2. No solution. Did you get an error message on the calculator? Yeah, and the reason why you did is because square root of 2. What is a decimal approximation for square root of 2? What is it? It's about 1.4. Well, think about your cosine graph. Where does cosine start?
0.
At 0, 1. It ends at 2 pi 1 for 1 period. Halfway is at negative 1. So a rough sketch of cosine, it looks something like this. So what's the highest cosine goes up to? 1. Well, if square root of 2 is right up here at 1.4, will that cosine curve ever reach 1.4? No, so that's why you're getting that error message on the calculator, because cosine, it can never be bigger than 1. Now, one more thing I do want to point out is another problem with that recursive formula. We're not going to work something completely out, but let's say I have answers of pi over 4, 5 pi over 4, and 9 pi over 4. Let's figure out what the recursive formula would be to write all possible solutions for x. So when you write your formula, what was the first solution? Pi over 4. And what do I have to add to pi over 4 to get to 5 pi over 4? I heard pi, is that right? Yeah. Because pi over 4 plus pi, if I get a common denominator, this would be pi over 4 plus 4 pi over 4, and that gives me 5 pi over 4. Now, do you add pi to get to the next one? Yeah. And if I add another 4 pi over 4, does that get me to 9 pi over 4? Yes. So this would be plus pi, and to show that I keep making revolutions, we have to put that k out in front. So plus k pi, where k is an element of the integer. So it's not always 2 pi that you add. You may add only pi over 4, or pi over 2, or pi over 6. So this value right here will change. So it's